This video is from our Chapter R review chapter, starting with section R.5 on factoring polynomials. Factoring is a critical skill that we'll need for most of the course, and so you really want to get it down now so you're not trying to learn it later. Okay, we'll start with factoring with the difference of two squares. What it says above here is that if you multiply x minus a times x plus a, the result is a difference of two squares, difference being subtraction. So factoring is just multiplication done in reverse. So we want to break this down into two factors. So following this pattern up here, but using a and b instead of x and a, we see that a squared minus b squared factors to a minus b times a plus b. Now, does it matter what order I write those in? Could I put a plus b first? Of course. It doesn't matter. 2 times 3 is the same as 3 times 2. It's just a preference, and you may do it different ways every time. Okay, let's look at the example for the difference of squares. The first one, right off the bat, they give us a difference, but these are not two squares. 3 is not a perfect square, nor is 27. So in the very first question, we have to ask, is there a common factor we should factor out of these two terms first? So this is where your calculator can help you if you don't know the factors of 27. Now 3 only has a factor of 3 and 1, but 27, is it divisible by 3? It is. So we would pull out that 3. 3 times what? X squared minus 9. Okay. Now, I'm going to put in an extra step here as we break down. We have a difference of two squares, because 9 is a perfect square, and of course x squared is. But I want to put in this extra step that you probably won't need on every problem. But I want you to avoid the mistake of going straight from this to x minus 9, x plus 9. Very common mistake. We need to identify a and b, not a squared and b squared. Okay? So what we'll do is I'm going to write this with brackets and say, okay, what is being squared? What is a? A is x, x squared. B is 3. 3 squared gets me that 9. So now I've got to keep the 3 because I'm saying this is equal to this is equal to this. If the 3 goes away, they are not equal, and I have made a big mistake. Okay, keeping the 3, now what's left? A minus b, x minus 3, a plus b, or in the other order. Of course, I'm saying b, and I want to write b. A x plus 3. Okay, so if we multiply this back together, we should get x squared minus 9. Then we distribute the 3, and we're back to the beginning. All right, let's look at the next one. It's a difference. Are these two perfect squares? Well, certainly 4 is a perfect square and 25 is a perfect square. Well, x squared is a perfect square and y to the 4th is a perfect square. Now, neither one of these terms have anything in common, so there's no way we could pull out a common factor. So let's just go straight to our trick of using the brackets and saying, well, what is a? What am I squaring to get 4x squared? Well, I'm squaring 2 to get the 4 and x to get the x squared. Minus, what am I squaring to get the 25 y to the 4th? Well, obviously a 5 will get squared to get me the 25. Y to what power squared gives me y to the 4th? Y squared. So now I've identified a and b, and I can go straight to a minus b, or plus a plus b. Okay, and if I FOIL this together, I should get back to 4x squared minus 25y to the 4th. Okay, we will continue with the next example in the next video.